Hi everyone, so today we are moving on to a new unit, Congruent Triangles. One of my favorites, although I do say that every unit, don't I? Okay, so we know that two figures are said to be congruent if they have the same size and the same shape. Okay, so we can't have a triangle and a rectangle be congruent, okay? So two triangles are actually congruent if and only if their vertices can be matched up so that all the corresponding sides and angles are congruent. Okay, so vertices, let's just make sure we understand. Vertices are these corners where the two sides meet. So a triangle is going to have three vertices. All right, so again, two triangles are congruent if and only if their vertices can be matched up so that all corresponding sides and angles are congruent. Now, I want you to think for a second and review what does if and only if tell me about the statement I just made. We're going to talk about that in class tomorrow. All right, so let's use this idea of congruent triangles. So if I make this statement, if triangle ABC is congruent to triangle DEF, then the congruent sides and angles will match up as follows. So the corresponding sides would be AB would correspond to DE. BC would correspond to EF, so those sides would be equal, and AC would correspond, segment AC would correspond to segment DF. Now when I'm doing this, I'm really methodical about it. I do AB to DE, BC to EF, and then AC to DF. All right, and then the corresponding angles that would pair up would be angle A would correspond to angle D, and they'd be congruent, obviously, because it's congruent triangles. And then angle B to angle E, and then angle C to angle F. Now, the important thing to note is that the statement itself is the most important thing. You may see triangles that don't appear to match up the way you'd like them to, but you always follow the statement. You always follow the statement if one is given to you. All right, so I'd like you to try now. Here I give you triangle FAR is congruent to triangle TMJ. I would like you to list the 6 pairs, because there will always be 6 pairs of congruent parts. Press pause and then come back and let's check it out. All right, so you're back. So I'm hoping you have FA congruent to TM. You have AR congruent to MJ. You have FR congruent to TJ, and then you have angle F to angle T, you have angle A to angle M, and you have angle R to angle J. Okay, and hopefully you're seeing this is that correspondence matching up the vertices that we were talking about. All right, so the definition of congruent triangles basically says that if two triangles are congruent, like we set up here. This is actually the definition. So let me just actually copy and paste that. Oh, I can't do that. Okay. Hold on. If two triangles are congruent, then all corresponding sides and angles. And then there's a statement that we're going to start talking about in class that really we can use as the definition of congruent triangles. We can say Cpctc. Cpctc. It means corresponding parts. It's the result of congruent triangles. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. And we're going to talk about that a lot this unit. All right, so we can actually move things around. I don't have to be so firm with my statements. Suppose you know that triangle FIN is congruent to triangle WEB. I'm allowed to rewrite them. You and I might write these differently just based on the way we look at them, but the pair up still needs to be the same. So could I say NIF, so go backwards, equals BEW? Yes, I absolutely could. You don't have to be firm in starting with F. I could start with N. I could start with I, as long as we pair up the corresponding parts. Now, suppose I still know triangle FIN was congruent to triangle WEB. Could I write it as INF EWB? So that's a case I can't. Look, if I go I to N to F, then it would have to be E to B to W. So that's that correspondence. So no, it's not correct to say it this way. This one was yes, this one was no. All right. So sometimes I'll be given triangles and I say that they're congruent and I have to write a correspondence statement. Now, in this case, we're going to use the diagram to help us, okay? I know that the O's are equal right here, and I can see that the B and the D pair up, and I can see that the A and the C pair up. So if I say A, B, O, and the way I do this, actually, let me back up. The way I do this is I follow my order, A to B to O. Right? So I'm starting at A, so I know that C kind of matches up with it. So C to D to O. So then I would write triangle CDO. Now, then I can fill in the blank. AO equals CO is congruent to CO. Angle A pairs up with angle C, and BO the length of BO is the same as the length of DO. So if this is true and AO equals OC, can you deduce that O is the midpoint of any segment? Well, we can absolutely say that it's the midpoint of segment AC. Now, if we use congruent triangles and take this one more step, and we can mark these congruent, then we can also say that it is the midpoint of DB. Okay? All right. Now, suppose that you know, even though I know it appears to be, but we don't know it, but suppose now I tell you that DB is perpendicular to AB, okay? They're perpendicular, or to DC. DB is perpendicular to DC. How could we deduce? How could we deduce that DB is perpendicular to BA? Well, we know that congruent triangles, we know that D pairs up with B, okay? Based on the, this statement, this congruent triangle statement. So if D is a right angle and perpendicular, then we know that these also would be right angles, making AB and BD perpendicular. So we can use these congruent triangles to do other things. All right, so we're going to try this again. So two triangles below are congruent, complete the statements. Okay, so PXY is congruent to PXY would be TXY. So triangle TXY. Okay, so angle P would be congruent to angle T. Angle T. Y. This is a great place to use Cpctc because of Cpctc, because corresponding parts of congruent triangles are congruent. All right, XP is congruent to XT. Why? Because of Cpctc. Corresponding parts of congruent triangles are congruent. Angle 1 is congruent to angle 2. Why? Because of Cpctc. Corresponding parts of congruent triangles are congruent. So now we can actually do a little bit more. Based on this one, based on D, then does YX bisects angle PYT. Angle PYT. Because of the definition of an angle bisector. Definition of an angle bisector. All right, last thing I want to do. Last thing. I give you a triangle. I tell you there are two triangles. I tell you they're congruent. Now I can use that to find the different measurements of angles. So if I know that H is congruent, angle H is congruent to angle T, then I know that these angles are congruent. So 6A minus 3 equals 51. Mark those diagrams, don't forget. So I'm going to add 3. So 6A equals 54, so A equals 9. Okay, same thing with K. K corresponds to S. Okay, so I got to do a little bit more work here. If this is 83 and this is 51, and K is congruent to S, I need to find S, the measure of S. And since I have two angles of the triangle, I can use the triangle sum theorem to find the third. So 83 plus 51 gives me 134. 180 minus 134 gives me, let's see, 46. So then I know that 7b minus 10 is equal to 46. So this was 46 degrees. So I'm going to add 10 and get 7b equals 56. So b equals 8. All right, guys, so that's my introduction to congruent triangles and corresponding parts. And tomorrow we're going to be learning about other things related to congruent triangles. Have a great day.